Hello there and welcome to Just About Earth, where quiet curiosity meets the deep end of science and wonder is allowed to take its time. Tonight we're not going to talk about how the universe began or where it's heading. Instead, we're going to look under our own feet and ask something a little unsettling, something simple but not easy. What if we're not the first? Not the first thinkers, builders, explorers? What if, long before pyramids and satellites and bedtime science channels, another civilization lived here on Earth, rose to something complex, and then vanished? I don't mean mythical lost continents or alien tourists. I mean an actual civilization. Something homegrown, biological, intelligent. Perhaps in ways we don't fully understand. Something that lived and died so long ago the planet may have forgotten it completely. If that sounds like the setup to a science fiction story, well, it sort of is. But it's also a serious scientific question. One that's been quietly bouncing around geology labs and cosmology conferences for years. The idea isn't that we'll find skyscrapers under Antarctica or smartphones embedded in coal seams. It's more subtle than that. The question is, if there had been an advanced civilization millions of years ago, could we even tell? Would the traces survive the slow, relentless grinding of the Earth's geology? Or would everything, cities, tools, language, even bones, have been recycled back into rock and soil indistinguishable from nature? Before we begin to explore what might be hidden beneath the layers of time, I'd love to know where in the world you're listening from tonight. And what time is it right now, where you are? Funny, isn't it? The topic is ancient civilizations, and yet here we are, separated by seconds and miles, quietly sharing this same little moment. No matter where or when you are, I'm glad you're here. If this kind of slow burn question is your kind of question, I'd be thankful if you tapped like or subscribed. It helps this sleepy little signal reach other curious minds. No pressure, of course, just an invitation like the faint trail of footprints that might, if we look closely, lead somewhere unexpected. So settle in, maybe lie back if you can, and let your thoughts slow down to the pace of plate tectonics. We're going to take a long look backward, not through human history, but through the crust and silence and heat of deep time itself. Because before we can ask whether someone came before us, we have to understand just how much time we're dealing with, and how good this planet is at wiping the slate clean. When we talk about ancient history, we usually mean a few thousand years. The pharaohs of Egypt, the builders of Stonehenge, the earliest known scripts etched into clay tablets. Even when we reach back to the dawn of human civilization, we're still only going back about 10 or 12,000 years. That's a blink in geological time. It's closer to now than to almost anything else that's ever happened on this planet. And yet, to us, it already feels like the deep past, already enough to fill libraries with mystery, debate, and speculation. But the Earth is old, staggeringly old, not just millions of years old, billions, about 4.5 billion years, give or take a few hundred million. For the vast majority of that time, there were no humans. There weren't even mammals for most of it, and for much of it, there was no life on land at all. Life spent a lot of time swimming or waiting or evolving in microscopic obscurity. And yet, despite how empty that sounds, this was when most of Earth's story was written. Layer by layer, rock by rock, in forms that speak slowly and forget quickly. The planet doesn't keep a diary. It doesn't preserve everything equally. Wood decays, metal rusts, bones dissolve, and time doesn't just pass, it acts. It buries, melts, crushes, shifts and erases. Mountains rise and crumble, oceans open and close, entire continents drift, collide and break apart. Every few hundred million years, the face of the world changes completely. And when you look at it this way, it's not that evidence gets lost. It's that surviving anything at all for more than a few million years is already an extraordinary event. So let's imagine, just as a thought experiment, what if, say, 100 million years ago, long after the age of the dinosaurs began but long before it ended, an intelligent species evolved, Something upright or not. Maybe land-based, maybe aquatic. Maybe it didn't build with stone or metal at all. Maybe it never needed to. Maybe it had technology of a kind we wouldn't recognize. Maybe it lived for a while, developed something we might even call culture or society. And then something happened. A shift, a catastrophe, or simply the slow fade of time. It disappeared. And now we arrive, millions of years later, asking whether we'd even know if it had been here. Because here's the hard truth. We're not as permanent as we like to think. Our skyscrapers, our highways, our libraries and satellites, none of them are built to survive geological time. Leave a modern city alone for a few centuries, and nature reclaims it. A few thousand years, and it's already hard to see what was once there. But a few million years, erosion, tectonics, subduction. By then the surface has changed. What was land might now be seafloor. What was mountain might be rubble. And most of our traces? Gone. This isn't science fiction. It's based on what we know from geology and archaeology. Traces of even recent prehistoric human activity are incredibly rare. Not because humans didn't do anything, but because Earth is an efficient recycler. Consider the fossil record. It's spotty at best. Not because life wasn't abundant, but because the conditions for fossilization are very specific. Most organisms that die are never fossilized. They decompose, they get eaten, they dissolve. To become a fossil, you need a rapid burial, mineral replacement, and protection from erosion. And then you need to get lucky enough for that rock to survive, get exposed, and be found. Multiply that challenge by tens of millions of years, and you start to see the scale of the problem. And it's not just bones. Buildings, artifacts, tools, even those made of metal, don't last forever. Most metals corrode. Most plastics break down, especially in sunlight or underground. Even concrete, if left unprotected, eventually crumbles. So if a civilization had existed in the distant past, especially one that didn't leave behind vast quantities of stone structures, we might never know. You might be wondering, has anyone ever seriously considered this? And the answer is yes. In 2018, two scientists, Gavin Schmidt and Adam Frank, published a paper exploring this very idea. They weren't proposing that such a civilization actually existed, but they were asking how you'd even detect it if it had. They called it the Silurian hypothesis, named somewhat cheekily after a fictional race of intelligent reptiles from a British sci-fi show. Their real question was more methodological. What kinds of traces would industrial civilization leave in the geologic record after millions of years? And could such traces already be there, misinterpreted as something else? They focused on markers, chemical signatures, anomalies, things like carbon isotope ratios, unusual concentrations of rare elements, synthetic molecules that don't occur naturally. In other words, they were thinking like detectives who can't find a body, a weapon, or a witness, but are hoping the wallpaper might still tell a story. And in doing so, they raised an uncomfortable possibility. Maybe the absence of evidence isn't evidence of absence. Maybe it's just how things look when a planet resets the surface every few 100 million years. Because civilizations don't just vanish cleanly, they leave waste. Energy use, agriculture, mining and manufacturing, all of these leave fingerprints, but fingerprints fade. And if a previous civilization had gone through its own industrial age or something equivalent, would we still see the effects in climate records, sediment cores, or the composition of ancient rocks? Maybe. Maybe not. Even now, our own impact on the planet is being written into the geologic record. This is sometimes called the Anthropocene, the proposed name for a new geological epoch marked by human influence. Plastic in the oceans, concrete in the soil, nitrogen in the atmosphere, radioactive isotopes from nuclear tests. If future scientists, whoever or whatever they are, dig into our present, they might find these markers. The question is, how long would those last? And how visible would they be if millions of years passed before anyone looked? This isn't just idle speculation. Thinking this way helps scientists test the limits of their methods. It's about understanding not just what we find, but what we're likely to miss. The geological record is full of gaps. Some periods are well preserved, others are almost entirely erased. Erosion can remove layers of sediment that took millions of years to build. Tectonic activity can fold, fault, and bury entire regions. And then there's the ocean, which covers more than 70% of the planet's surface and hides countless secrets beneath miles of water and sediment. Most of the Earth's surface is geologically young. That is, it's been resurfaced or altered within the last few 100 million years. Even the ocean floor gets recycled. Through a process called subduction, old seafloor is pushed under continental plates and melted back into the mantle. That means if an ancient civilization had built anything near the coast or on an island, or worse, in a now submerged region, those traces might be long gone. And yet, we're here now, building, recording, observing. We wonder whether we're alone in the universe, but rarely ask if we've ever truly been alone on this planet. Maybe the past was quieter than we think, or maybe we've just lost the ability to hear it. We'll pick that up shortly, as we look more closely at what could survive, what couldn't, and whether we've already stumbled across traces without realizing it. There's more to this story, more layers, both literal and scientific, and we'll keep moving gently through them, one at a time. Alright, let's slow down and ask something basic. Before we go looking for lost civilizations, we should probably decide what we're even looking for. What exactly is a civilization? And what would make one count scientifically speaking? In everyday conversation, we tend to think of civilization as a kind of upgraded version of society. Cities, writing, governments, maybe a skyline. But that's a very narrow, very modern view. Even in human history, civilizations have looked wildly different. Some built vast cities with monuments and roads. Others left almost nothing behind but language and land use. And yet we'd still call them civilizations. In archaeology and anthropology, the definition gets a bit more careful. Civilizations are usually identified by a set of traits: urban centers, specialized labor, centralized authority or governance, surplus agriculture, organized religion, social stratification, the development of writing or symbolic communication, long-distance trade. Those are the big ones. But not all civilizations tick all the boxes, and some do it in ways we might not expect. So when we talk about the possibility of a forgotten or deeply ancient civilization, we need to broaden our thinking. We're not necessarily looking for giant pyramids or computer chips. We're looking for evidence of complexity, social, technological, or ecological. Things that don't happen by accident. Things that suggest a group of beings organized themselves at scale, over time, for purposes that went beyond survival. It's helpful to think about civilization less as a finish line and more as a spectrum. Somewhere between isolated survival and planetary engineering, there's a lot of room. A culture of tool users that created structures or systems beyond individual lifespans. A species that learned to store knowledge, pass it on, and modify its environment deliberately. That might not sound like much, but it's huge in evolutionary terms. And if it happened more than once on this planet or anywhere else, it's worth taking seriously. Let's look at an example closer to home. Take the ancient city of Çatalhöyük in modern-day Turkey. It's about 9,000 years old. No streets, no monuments, no written language. Just densely packed homes, built side by side with no doors. People entered through the roofs, yet it's considered one of the earliest known urban settlements. Because what matters isn't the skyline, it's the pattern. Coordinated building, long-term settlement, shared rituals, food production, burial customs. Even without grand architecture, it's a sign of collective behavior over generations. Go back further, and the clues get even more subtle. The earliest evidence of symbolic thinking in humans comes from tools, pigments, carvings, things that imply planning, memory, perhaps even belief. Not technology in the modern sense, but still technological in its own context. Evidence that minds were working in abstract ways. So now imagine a civilization that existed not 10,000 years ago, but 10 million, or 100 million. What would we expect to find? It depends a lot on what they were like. If they built with organic materials, wood, plant fiber, animal products, those materials wouldn't last. If they buried their dead with rituals but not with durable artifacts, we might find bones but miss the meaning. And if they never developed writing, or used a form we don't recognize as writing, their stories might be lost completely. Worse still, if they didn't live on land, or spent most of their lives in environments that don't preserve fossils well, our chances of detecting them shrink even further. If a civilization arose in a rainforest, on a coastline, or in a swamp, most of its remains would be gone within a few centuries, let alone millions of years. It's not a matter of hiding, it's a matter of time. We also have to be careful not to project too much. We're used to seeing intelligence in the form we exhibit: language, tools, cities, and now digital technology. But intelligence doesn't have to look like us. A civilization might not be industrial at all. It might organize its society in ways that don't leave big material traces. It might communicate chemically or visually or through forms of behavior we don't even have words for. And that brings up a strange problem. Would we even recognize it as a civilization? Think of a termite mound. To us, it's a nest, a big pile of dirt, but in terms of engineering it's a marvel. Internal climate control, air circulation, resource storage. The termites build collectively. They farm fungus. Their colony behaves as a single organism. If we didn't know what we were looking at, we might mistake it for a natural structure, scale it up by a factor of 1,000, or bury it for a few million years, and even that trace might disappear. So when we think about lost civilizations, we need to think like archaeologists, and like biologists. We're not just looking for ruins, we're looking for patterns, anomalies, disruptions, unexpected concentrations of minerals, changes in sediment that don't match known processes, strange isotope ratios, things that might suggest someone, or something, was here doing something unusual. There's also the question of duration. How long would a civilization have to exist to leave a mark? Not very long, geologically speaking. Humans have transformed the entire planet in just a few hundred years of industrial activity. In terms of sediment, that's barely a dusting. But the chemical impact is measurable. Greenhouse gases, synthetic compounds, nuclear isotopes. Even if we vanished tomorrow, some of those changes would still be detectable for tens of thousands, maybe millions of years. So maybe the better question isn't whether a previous civilization existed, but whether we're even asking the right questions to detect it. We look for signs that make sense to us. Fossils, ruins, tools. But what if the signs are stranger, smaller, or in places we haven't thought to look? We'll keep going. Because to answer this question fully, we need to look at how the Earth behaves over long spans of time. Not just centuries or millennia, but entire epochs. And that means looking at the forces that erase, what stays, what fades, and why. If you want to hide something forever, you don't need to bury it deep or burn it up. You just need to leave it on the surface of the Earth and wait. Not days or decades, but long enough for geology to do its work. Because the Earth is not still. It breathes, it shifts, it consumes, and almost everything built on top of it eventually disappears. We don't notice this much in everyday life. We tend to think of landscapes as permanent. Mountains seem eternal. Rivers always seem to be in the same place. Cities feel like they've always been where they are. But geologists see something else. They see motion in what looks solid. Over enough time, even the hardest rock flows, bends, or breaks. Even the tallest peaks crumble. The surface of the Earth is constantly being reworked, and that means anything resting on that surface is temporary by default. Start with weathering. Rain, wind, frost, heat. All of it slowly chips away at anything exposed. Cliffs erode grain by grain, roots push through concrete, metals oxidize, organic matter rots. It doesn't take long for buildings to become ruins, and then for ruins to become barely distinguishable piles of debris. And if those remains aren't preserved under special conditions, rapid burial, arid climate, deep freeze, they're as good as gone in geological terms. Then there's sedimentation, soil, sand, dust, ash. All of it builds up over time, layer by layer, burying whatever's underneath. Sometimes this helps preserve artifacts or fossils, but it can also crush and distort them. Layers compress into rock. Organic materials get broken down or replaced by minerals. And after a few million years, that buried city or skeleton might be a vague imprint in a chunk of limestone, if it's there at all. Tectonic activity is another key player. The Earth's outer shell isn't one solid surface. It's a patchwork of plates that float on a slow-moving sea of molten rock. These plates collide, pull apart, and slide past each other. When they do, they create earthquakes, raise mountains, open new seafloors, and drag old ones back into the mantle. This last process, subduction, is especially important. It means that entire sections of the ocean floor are gradually pulled under continents and recycled. Whatever was on them, sediment, fossils, cities, melts and becomes part of the Earth's interior, not buried, erased. The average age of the ocean floor is only about 200 million years, which sounds old until you remember the Earth is over 4.5 billion years old. That means most of the planet's seafloor has been replaced many times over. If an ancient civilization had lived near the coasts or on islands, there's a real chance their traces would now be at the bottom of a tectonic plate, turning slowly into magma. Continental surfaces last longer, but even they don't keep a perfect record. Erosion wears them down, glaciers scrape them clean, volcanic eruptions coat them in ash and lava, forests come and go, deserts migrate, rivers change course, even massive impact craters can fade over time. What looks permanent from our human perspective is often just the current state of something in motion. The Grand Canyon is often held up as a great geological archive, layers of sedimentary rock stacked like the pages of a book. But that book is missing chapters. There are gaps where layers were never deposited or were removed later by erosion. These gaps are called unconformities, and they're a reminder that the geological record isn't complete. It's a patchwork stitched together from what happened to survive. And survival is rare. The fossil record, which we use to understand ancient life, is incredibly incomplete. Most organisms don't fossilize. Even those that do are only found when erosion or excavation exposes them. It's not that fossils are common and we just haven't looked everywhere. It's that fossils are incredibly rare and most are gone for good. If that's true for bones, literal pieces of living organisms, it's even more true for cultural artifacts. Tools, buildings, inscriptions, technology. Even with humans whose artifacts are only tens of thousands of years old, we often find fragments. A flint knife, a piece of pottery, a post hole in ancient soil. Archaeologists reconstruct entire societies from scraps because that's usually all that remains. So when we ask whether another civilization could have existed millions of years ago, the burden of proof is enormous. It's not just that we haven't found their ruins. It's that the odds of anything surviving that long are already vanishingly small. And even if something did survive, it would have to be in a place that hasn't been subducted, eroded, buried too deeply, or completely changed. Consider how we look for impact craters. Large asteroid impacts leave scars, craters hundreds of kilometers across. But some of these craters are hard to see because over time they're eroded, buried, or deformed. Some we only detect through gravity anomalies or subtle changes in rock composition. Now, imagine trying to find something smaller than a crater. A city, a factory, a carved monument. Unless it was preserved in a perfect geological niche, it would be extremely difficult to detect. And preservation alone isn't enough. Someone has to be looking in the right place, at the right time, with the right tools and the right questions. Most paleontological digs aren't looking for signs of intelligence. They're looking for species, bones, ecosystems. They examine sediment layers for traces of life and extinction events, not for signs of roads or buildings. And if an object doesn't look artificial, if it isn't shaped like a tool or clearly manufactured, it might not be recognized for what it is. Even when we do find something unusual, the first assumption isn't civilization, it's natural process. And that's a reasonable bias. Nature is capable of producing very complex structured patterns: crystals, geodes, erosion features, mineral veins. Without context, it's hard to tell what's natural and what's artificial. A perfect sphere might be a decorative object, or it might be a concretion. Without surrounding evidence, it's just a curiosity. This is part of why the Silurian hypothesis focuses on indirect evidence. Rather than looking for buildings or tools, it asks whether an earlier civilization might have altered the Earth's chemistry or climate in a detectable way. In other words, not what they built, but what impact they had. Even that's hard to trace, because natural events can produce similar changes. A volcanic eruption, a methane release, a mass extinction. All of these leave chemical fingerprints that can look similar to industrial activity. So the challenge isn't just finding evidence, it's interpreting it. And that requires humility. Not because the idea is likely, but because ruling it out completely requires more certainty than the planet tends to allow. We think of history as a straight line with a clear beginning and clear end. But the geological record doesn't care about lines. It cares about pressure, heat, erosion, and deposition. It rewrites itself constantly. And that means most of what happened on Earth, most of what was ever built, spoken, thought, or dreamed, is gone. Not hidden, just undone. We're not done, though. If the Earth is good at erasing, then we need to understand what resists that erasure. What can last, not just for centuries, but for millions of years. So next, we'll look at the kinds of evidence that might endure and how we could recognize them. Not fossils, not buildings, but something subtler, something more chemical than architectural, more stubborn than stone. When people hear the word fossil, they often picture a perfectly preserved dinosaur skeleton, laid out in a museum, bones arranged just so like the creature lay down and simply became stone. But real fossils rarely look like that. They're fragmented, partial, compressed. They take luck, very specific environmental conditions and time. Even under the best circumstances, fossilization is an exception, not the rule. And the story it tells is often incomplete, selective, and quiet on many important details. The fossil record is one of the best tools we have for understanding ancient life, but it doesn't give us a full picture. It's like trying to reconstruct an entire movie from just a few still frames, some torn film, and a few scattered subtitles. For every species we've identified in the fossil record, there are likely dozens or hundreds that have left no trace at all. Some never fossilized, some did, but the remains were destroyed. Others still lie buried in places we haven't explored. So when we talk about ancient civilizations, especially hypothetical ones, it's important to keep in mind that we're already working with a record full of blind spots. Fossilization depends on a combination of factors: how and where an organism dies, what kind of sediment it's buried in, how fast that sediment accumulates, whether scavengers get to the body, whether the site is geologically stable, and whether erosion or tectonic activity later exposes the fossil without destroying it. That's a lot of conditions. The odds are stacked against preservation from the start, and for most of Earth's history, the places where life thrived, coasts, floodplains, forests, weren't great for fossilization. They were too active, too wet, too exposed. Now imagine trying to preserve not just bones but artifacts, tools, structures, infrastructure. Things that don't even begin with the durability of bone or shell. The odds drop even further. Even stone tools, which are relatively resilient, can be hard to date and identify if they're out of context. A chipped rock might be a tool, or it might be just a chipped rock. Without patterns of use or associated artifacts, it's difficult to say. And most technological material doesn't survive the way bone does. Metal corrodes, fabric decomposes, plastic breaks down, unless it's buried in an oxygen-free environment. This means that even for our own ancestors, the record is incomplete. Take Homo erectus, a species that existed for nearly 2 million years. We have tools, bones, and some evidence of fire use, but much of what they did is unknown. They travelled widely, adapted to different climates, and likely had forms of communication, but we don't know what they believed, how they organised themselves, or what they dreamed. Not because they didn't leave signs, but because those signs didn't survive. When we dig into the fossil record, we're digging into the survivors, the lucky ones, the ones whose remains happen to fall in the right spot under the right sediment, away from too much pressure or heat. That's why periods of mass extinction leave such distinct layers. There's often a sudden die-off, a lot of material getting buried quickly, and less time for decay to erase the evidence. The layers where we find the most fossils are often moments of crisis, not moments of civilization. So if we were looking for evidence of a past intelligent species, we might only find them if they lived near one of these rare, fossil-friendly zones, and then were caught in a preservation-friendly disaster. It's a narrow window, and that's assuming they left bodies at all. Intelligent life, especially if it developed advanced technology, might have disposed of its dead in ways that don't promote fossilization. Cremation, sky burials, sea burials, decomposition in designated places. And beyond that, there's a more subtle issue. What if a civilization advanced to the point where it stopped leaving biological remains entirely? What if it transferred its thinking into artificial systems, or evolved into something less physical, more distributed, less organic? We don't know if that's possible, but if it were, the fossil record wouldn't just be silent, it would be irrelevant. Even now, most of the matter involved in our day-to-day lives is synthetic, non-organic, or so processed that it wouldn't register as natural to someone studying our remains millions of years from now. A future geologist might find layers of strange polymers, rare earth elements, and metal alloys, and not recognize them as remnants of a civilization, especially if the context is missing. Imagine finding a thin layer of titanium dust in a 100-million-year-old sediment core. It might raise questions, or it might be dismissed as an anomaly. Interpretation is as important as observation, and that brings up something often overlooked in discussions of the fossil record: bias. Not just in what gets preserved, but in how we analyze it. We see what we expect to see, and the idea that a civilization might have come and gone millions of years ago doesn't fit comfortably into most scientific frameworks, so unless the evidence is overwhelming, it's likely to be classified as natural variation, or an unexplained anomaly. Not because of negligence, but because that's how science works. It prefers the simplest explanation that fits the evidence. And civilizations, especially ancient, vanished ones, are not simple explanations. This is why the fossil record doesn't tell us everything. It tells us what the planet allowed to be preserved. It tells us what we happen to find. It tells us what we're able and willing to interpret. But it doesn't tell us the full story of life on Earth. And it certainly doesn't tell us everything about intelligence. Still, we have other tools. Not just bones and artifacts, but signals. Signs in the soil, in the atmosphere, in the chemistry of rocks. Traces left, not by bodies, but by processes. And that's where we'll go next, into the kinds of evidence that don't rely on fossilization. That aren't about bones at all, but about what happens when something starts to change the planet it lives on. When intelligence leaves a fingerprint not through tools or cities, but through chemistry. In 2018, a pair of scientists named Gavin Schmidt and Adam Frank posed a question that managed to be both wildly speculative and scientifically grounded. They asked, if an industrial civilization had existed millions of years before humans, would we be able to detect it in the geological record? They weren't arguing that such a civilization did exist. Instead, they were exploring how science would even begin to look for one. And in doing so, they gave this question a name, the Silurian hypothesis. The name is a nod to a British science fiction show where intelligent reptiles, the Silurians, had once ruled the Earth before humans. But the hypothesis itself isn't about science fiction. It's about testing the limits of geology and paleoclimatology. It's about asking whether our own impact on the planet is unique, or if it could resemble something much older, hidden deep within the Earth's layers. The premise is simple. If an industrial civilization like ours had developed, say, 50 or 100 million years ago, and then vanished, what traces would it leave? And would those traces survive the erosion, burial, and tectonic upheaval that follows over that kind of time span? The scientists began with what we already know, that our own civilization is leaving geological fingerprints. We're changing the composition of the atmosphere. We're altering the chemistry of the oceans. We're depositing synthetic materials like plastics, pesticides, and industrial byproducts into soils and sediments. These are long-lived global changes that are being recorded in the Earth's layers, right now. So the question becomes, what kinds of changes are the most durable? And would they look any different if they were created by an earlier civilization rather than by us? The paper breaks it down into a few major categories of evidence. One is geochemical anomalies, changes in the ratios of stable isotopes such as carbon, oxygen, and nitrogen. For instance, burning fossil fuels changes the balance of carbon isotopes in the atmosphere. This shift gets preserved in sediment layers and ice cores. If something similar happened in the distant past, it might suggest an industrial process, even if the civilization itself is long gone. Another category is synthetic materials. Our modern world produces plastics and chemicals that don't occur naturally. Many of these compounds degrade slowly and could, in theory, survive for millions of years in some form. Tiny particles of plastic, called microplastics, are already turning up in sediments, oceans, and even the air. If we find ancient layers with similar non-natural polymers, we'd have to consider where they came from. There's also the question of fossil fuel use. Industrial civilizations require energy. If a previous one burned carbon-based fuels, that would release not just CO2, but also leave behind coal ash, fly ash, and other distinct byproducts. These could accumulate in layers and might be detectable, just like we can detect layers of volcanic ash from ancient eruptions. Then there are mass extinctions. Human activity has already accelerated extinction rates across many species. This kind of biological signature, a sharp drop in biodiversity, especially of large animals, can leave a visible mark in the fossil record. If something similar happened in the past, without an obvious natural cause like an asteroid or volcanic eruption, it might hint at an industrial agent. But here's where things get tricky. Many of these same markers could also be caused by natural processes. For example, the Paleocene-Eocene thermal maximum, about 56 million years ago, saw a rapid rise in global temperatures, ocean acidification, and a major disruption in the carbon cycle. It left behind some of the same geochemical fingerprints we're producing now, yet, as far as we know, no civilization was involved. So how do you tell the difference between a natural event and one caused by intelligence? That's the hardest part. The Silurian hypothesis doesn't claim that we found proof of a past civilization. It asks whether we'd even recognize that proof if it existed. And more importantly, it asks us to think about what traces we ourselves are leaving and how long they'll last. Because even our most enduring markers, plastics, nuclear isotopes, industrial byproducts, aren't guaranteed to survive for tens of millions of years. They might degrade, be buried too deeply, or get erased by subduction and resurfacing. Even if some survive, they might be scattered and hard to interpret without a broader context. This forces a shift in thinking. Instead of looking for traditional ruins, buildings, tools, roads, we need to think like planetary archaeologists. We need to look for subtle, indirect clues, chemical shifts, anomalies in sediment layers, disruptions in ecological patterns. And we need to be open to the idea that some of the weird features we already see in the geological record might have alternative explanations. This isn't a call for conspiracy or fringe theory. It's a framework for asking better questions, for treating the possibility of pre-human civilizations as a scientific hypothesis, not a myth or a legend. And like any scientific hypothesis, it can be tested, challenged, refined, or ruled out based on evidence. It also makes us confront a deeper point. If we, with all our technology and global reach, are still geologically fragile, if our legacy might vanish in a few million years, then how many other stories might have already come and gone, lost to time not because they were small, but because Earth is patient and time is thorough? The Silurian hypothesis doesn't tell us that someone came before. It just tells us that if someone did, their traces would be hard to find, and it gives us a starting point to think about what to look for, how to interpret it, and what it would mean, not just for science, but for how we see ourselves in the story of this planet. And so we move forward. If such traces do exist, they won't come to us as statues or scripts. They'll be found in rocks, in chemistry, in thin layers of strange compounds. And the real question becomes, have we already found any of them without realizing what they were? If tomorrow every human being vanished, no warning, no war, no apocalyptic flare, just gone, what would the world look like a year from now? 100 years? 1,000,000? It's a grim but oddly useful thought experiment, one that helps us understand what kind of trace a civilization like ours really leaves behind, and more importantly, how long any of it might stick around. In the first few days, not much would change. Cities would still be lit, cars would remain where they last parked, planes grounded on runways, but very quickly, without human oversight, the systems that support our world would begin to fail. Power plants would shut down, water systems would lose pressure, buildings would start to decay, not because of some catastrophic event, but because nothing is built to run indefinitely without maintenance. After just a few years, nature would start reclaiming our cities. Plants would grow through cracks in pavement, roots would lift sidewalks, seeds blown in by the wind would take hold in abandoned gardens and rooftops. Animals would return, not just rodents and birds, but deer, coyotes, and eventually larger predators in some places. Without us, the line between wild and built would begin to blur quickly. In places like New York or Shanghai, subways would flood within days once the pumps fail. Steel structures would rust, glass would shatter. Within decades, many buildings would collapse under their own weight, especially in wetter climates. Concrete, though seemingly durable, is vulnerable to moisture and temperature changes. Rebar inside corrodes, cracks form, and the structure weakens. Roads would break apart more slowly, but they too would degrade. Vegetation would tear through asphalt. Bridges, lacking paint maintenance and structural checks, would eventually fall. Satellites in orbit would start to fail as batteries wear down and solar panels degrade. Most would deorbit and burn up within a few centuries, leaving only the most distant, slow-decaying objects floating silently overhead. After about 1,000 years, much of what defines our presence would already be unrecognizable. Steel structures would have collapsed or rusted into heaps. Plastics exposed to sunlight would degrade into fragments. Underground cables and pipes would corrode. The outlines of roads and cities might still be visible from the air, especially in drier regions, but they'd resemble faint scars more than signs of life. 10,000 years on, even those scars would begin to fade. Forests would fully reclaim temperate zones. Deserts would shift. burying cities, coastlines might change due to erosion or climate effects already in motion. Whatever is left would depend on location and material. Stone carvings might survive longer, think Mount Rushmore or the pyramids, but most modern infrastructure wouldn't. Go further, 100,000 years, and almost every surface structure would be gone. Only the deepest foundations, the most stable landfills, and certain geological modifications, mines, quarries, altered sediment layers, might still be detectable. But even these would be weathered, filled in, or buried, and any meaning they once carried would be long forgotten, unless decipherable patterns or chemical residues remained. So then ask, after 1 million years, what would survive? The answer is not much. Maybe a few artifacts in stable, dry environments, sealed caves, deep underground storage, or polar ice. Maybe some synthetic molecules that resist degradation. Maybe layers in lake beds or ocean sediment that show spikes in carbon, nitrogen, plastic residues, or rare earth metals. These would be the real fossils of civilization. Not buildings, but chemical echoes. If we disappeared tomorrow, the planet would begin erasing us almost immediately. Not maliciously, just mechanically. Erosion, biological decay, plate tectonics, all the usual processes of geology would continue just without interruption. And in time, the idea that we had ever been here would become harder and harder to prove. This isn't just philosophical. It's central to the question of lost civilizations. Because if ours could be wiped away so thoroughly, with all our global reach and technological intensity, then how could we expect the traces of any earlier civilization to have fared better? It also gives us a benchmark. If something about us can last, if anything at all leaves a durable global signature, then perhaps that's what we should be looking for when we ask whether we were the first. Not monuments, not artifacts, but residue, transformation, chemistry. And there's another layer. Some of our most persistent markers aren't things we built, but things we changed. The carbon we've released into the air, the nitrogen we've added to the soil, the isotopes from nuclear testing, the extinction of species and redistribution of biomass. These aren't structures, they're planetary modifications, and they're harder to undo. So now imagine you're a scientist, millions of years in the future, digging through a core sample of ancient sediment. You see a thin, strange layer, higher levels of carbon, a drop in biodiversity, traces of synthetic compounds, maybe even isotopes that shouldn't be there. You might ask, what happened here? Was it natural? Or was there something else? That's where this thought experiment takes us. By imagining our own disappearance, we get a clearer sense of what kinds of evidence actually endure, what would rise to the level of a geological signal, and what, unfortunately, would simply disappear. Next, we'll follow that signal, what it looks like, where it goes, and how it might be mistaken for something else. Because even if we leave a mark, the challenge is recognizing it for what it is. Geologists don't speak in years the way the rest of us do. They speak in layers, in thicknesses of sediment, in isotopes and core samples. Deep time doesn't count seconds or seasons. It works in intervals, events, patterns that stretch beyond the scale of memory, history, or even biology. And if we want to ask whether another civilization might have existed in the ancient past, we have to learn to think in that language. Because deep time doesn't describe what happened last week. It tells you what's written in the rock. Most of what we know about Earth's past comes not from fossils, but from the chemistry and structure of sediments. That includes ocean cores, lake beds, glacial ice, and the bands of rock exposed in cliffs and quarries. These layers form gradually depending on the environment, dust settling in lakes, shells accumulating on the ocean floor, ash falling from volcanic eruptions. The result is a kind of archive, with each layer offering clues about what the planet was like at the time it was deposited. This is the language of deep time, and while it doesn't speak in full sentences, it has a vocabulary. Carbon levels, oxygen isotopes, sulfur ratios, pollen grains, trace metals, magnetic orientation. It tells us about climate, about atmospheric composition, about what kinds of plants were growing and which species were abundant. It can even tell us about catastrophic events, asteroid impacts, supervolcanoes, mass extinctions, and in rare cases it hints at something weirder. Some of the most detailed records come from places that change slowly and preserve well: ocean floors, undisturbed lake beds, and the deep layers of polar ice. Scientists drill long cylindrical samples called cores and examine the layers centimetre by centimetre. They look for chemical shifts, variations in particle size, fossil content, mineral presence. Sometimes, a shift in colour is enough to signal a change in the world. These signals aren't always obvious, many are subtle: a slight increase in a particular isotope, an unusually high concentration of a rare element, a ratio of carbon-13 to carbon-12 that doesn't match the expected baseline. Taken alone, any of these might be natural. Taken together, especially in a narrow slice of sediment, they suggest something happened, something sudden or unusual enough to alter the long, steady rhythm of the planet. The Anthropocene, for example, the proposed geological epoch marking human influence, is already leaving a fingerprint. Future geologists, if they look, will likely see a spike in carbon dioxide levels, a drop in biodiversity, traces of synthetic chemicals, and fallout from nuclear testing. This thin line in the Earth's crust will stand out against the background rhythm of prior ages. It's not a full story, but it's a disturbance, a marker, and that's exactly the kind of thing scientists today are trained to notice. So if an earlier civilization had changed its environment in similar ways, even without leaving fossils or ruins, we might expect to find comparable signals, but interpreting them is another matter. Because for every spike in carbon or trace of a rare metal, there are natural explanations too. Volcanoes can release carbon, asteroid impacts can scatter iridium, microbial blooms can leave odd chemical residues. The planet has its own vocabulary of disaster, and it's easy to misread the source of an anomaly if you assume all causes must be natural. This is why context matters. It's not enough to find a chemical signature. It needs to line up with other evidence. A temperature rise that coincides with mass extinction. A strange compound appearing globally, not just locally. A sudden jump in heavy metals alongside fossil fuel indicators. Only by assembling these pieces can we begin to suspect something more than chance or catastrophe. And even then, we're guessing. The deeper into time we look, the fewer tools we have for certainty. Many of the most dramatic geological events occurred hundreds of millions of years ago. Whatever clues they left behind have been stretched, folded, buried, and exposed more than once. Rock is durable, but it's also changeable. Signals get scrambled, layers disappear, nothing stays clean. Still, some signals are stubborn. There are isotopes that decay so slowly they act as time markers for millions of years. There are shifts in magnetic orientation that match known cycles in the Earth's magnetic field, giving us a kind of planetary calendar. There are minerals that form only under specific conditions, certain temperatures, pressures, or chemical environments. These are the phrases, the punctuation marks in deep time's language. If a civilization affected the world strongly enough, and in just the right way, those effects might show up here. But the tricky part is recognizing them. Even now, scientists occasionally find unexplained anomalies, spikes or shifts that don't match known events. Most are eventually attributed to natural causes. Some remain unexplained, sitting quietly in the literature, neither dismissed nor pursued. Not because they're unimportant, but because without more context there's not much else to do. Science needs patterns, not just points. And that might be where the traces of an ancient civilization would sit, hidden in plain sight, misfiled as a natural event. If the signature was brief, or faint, or localized, it might not raise alarms. Or it might be attributed to something like a volcanic burst, or a methane release, or a sudden climate fluctuation caused by orbital changes. All of these are known phenomena. All have occurred many times. To say something intelligent did this is a bold claim, one that requires not just unusual data, but a framework to explain why intelligence is the most likely source. Without that, even a correct hypothesis would likely be ignored. That's not a flaw in science. It's part of how science protects itself from wishful thinking. But it does mean that some possibilities, however intriguing, remain unexplored. So the language of deep time is real. It's there in the rock, in the chemistry, in the slow rhythm of sediment and isotope. It tells us what changed, roughly when and often how, but not always why. That part requires interpretation, inference, sometimes imagination. And it's in that interpretive space that the question of lost civilizations continues to sit. Unproven, unprovable perhaps, but not impossible. Next, we'll explore what signs might still exist, those stubborn pieces of the puzzle that refuse to fade. Not the grand structures or stories, but the leftovers, the scraps, the accidental fossils of intelligence, if any exist at all. Because if something came before us, the odds are it didn't intend to leave a monument. It simply lived. And in doing so, may have changed the planet in ways it couldn't have known would one day become questions. Some things vanish quickly. Paper, cloth, wood. Others hang around a little longer. Glass, metal, concrete. And then there are things that outlast civilizations, not because they were meant to, but because they just happen to resist the forces that usually take everything else apart. When we talk about the potential traces of an ancient, unknown civilization, we have to think in those terms, not what was built, but what lasts. And it turns out the list is short. One of the most persistent markers a civilization can leave isn't architecture or technology, it's chemistry. When we mine metals, synthesize compounds, burn fuels, or alter the composition of the atmosphere, we're changing the planet in ways that can be written into sediments and soils. Those changes are often microscopic, but they're widespread. And when they occur fast or globally, they leave sharp signatures. Future scientists might not know what happened exactly, but they'll know something did. Let's start with synthetic materials. Modern humans produce a staggering variety of substances that don't occur naturally. Plastics, pesticides, industrial chemicals, rare metal alloys. Some of these break down quickly when exposed to sunlight or oxygen. Others are remarkably persistent, especially when buried. Microplastics, for instance, are already turning up in the most remote sediments, deep ocean floors, polar snow, high-altitude soils. Some studies suggest they could remain intact for tens of thousands, maybe hundreds of thousands of years under the right conditions. But even plastic has its limits. Left near the surface, it degrades. In oxygen-free environments, it might last longer, but it becomes harder to detect. And plastics alone don't prove intelligence. A layer of strange polymers might raise questions, but without context, without evidence of deliberate production, it might just look like an odd natural deposit, especially if everything else has disappeared. Then there's metal. We tend to think of metal as durable, and it is, but only under the right circumstances. Most metals corrode over time. Iron rusts, copper oxidizes. Even stainless steel, which resists corrosion, doesn't hold up forever. Metal artifacts might last a few thousand years if left untouched in a dry environment, but millions of years? Unlikely. Unless they were sealed in a highly stable environment, say inside a mountain or deep underground, there's not much chance they'd survive intact. And even then, they'd be hard to distinguish from natural ore, unless shaped or patterned in very obvious ways. Radioactive isotopes are a little different. Some are synthetic, created only through nuclear reactions. These include isotopes like plutonium-244, or certain transuranic elements that don't occur naturally in significant quantities. If found in the geological record outside of known nuclear events, they might suggest technological activity. but most have half-lives short enough that they decay to background levels over millions of years. Still, some isotopes, like technetium-99 or iodine-129, persist long enough that traces could remain under the right conditions. Fossil fuel combustion is another possible signal. Burning coal or oil releases carbon dioxide with a distinct isotopic signature. Specifically, a lower ratio of carbon-13 to carbon-12. If this kind of shift appeared suddenly and globally in ancient sediments, it might suggest large-scale combustion. But again, there are natural processes that can cause similar patterns, including volcanic activity and methane releases. We'd need additional clues to support a technological source. Another possibility is unusual concentrations of certain metals, like lead, cadmium, or rare earth elements, often used in electronics and manufacturing. Mining and refining these elements leaves waste. If found in high concentrations in ancient soils or sediments, especially in patterns that suggest processing rather than natural distribution, they could be evidence of industry. But these elements move through ecosystems in complex ways. They bioaccumulate, they leach, they migrate. Isolating a source isn't easy. What about physical structures? Deep, massive earthworks, things like quarries, tunnels, or underground facilities, might survive longer than surface buildings, especially if they altered the local geology. But identifying those after tens of millions of years would be difficult, especially if tectonic forces have shifted or buried the region. Erosion, collapse, and sedimentation can erase even large features. And without clear artificial geometry, it's hard to distinguish a mined cavern from a natural cave. Concrete is surprisingly durable, and some forms can actually strengthen over time due to mineralization. Ancient Roman concrete, for example, has survived for over 2,000 years, often in marine environments. Modern formulations might last longer, but again, exposure matters. Moisture, temperature shifts, and biological growth all take their toll. And in deep time, even concrete can become unrecognizable. Just another odd formation in the rock. Ceramics and glass are better. They're chemically stable, and shards of ancient pottery are often among the most persistent human artifacts. Under the right conditions, ceramic fragments could last for millions of years, especially if they were buried and not exposed to cycles of freezing and thawing. But fragments alone tell little. They'd have to be shaped, patterned, or present in large, unlikely concentrations to suggest artificial origin. Then there are indirect signals, changes to ecosystems, food webs, or soil chemistry. Modern agriculture transforms landscapes. It compacts soil, depletes nutrients, alters erosion patterns. Irrigation changes water chemistry. Fertilizers leave chemical residues. Deforestation and monoculture reduce biodiversity. Even after abandonment, these effects persist. And while nature reclaims the land, the scars might remain in soil profiles for thousands, maybe tens of thousands of years. Not enough for deep time, but more than most human-made objects. All of this means that if a past civilization existed, the most durable signs would likely be subtle. Not monuments, but patterns. Not artifacts, but anomalies. Something in the sediment that doesn't belong. A disruption in the slow rhythm of natural cycles. And those signs would have to be found, identified, and interpreted correctly. No small task when working with rocks that are already older than most species. Meanwhile, the signs that don't last are all around us now. Books, photos, art, music. The content of our lives. They're the first to go. Paper burns. Hard drives degrade. Digital signals vanish when the power goes out. Cultural knowledge, the stories, symbols, meanings, disappears even faster than buildings. Within a few generations, even among survivors, languages can die out, beliefs can fade, and once central truths can become mysteries. So we come back to the question, what lasts? Not much, but maybe just enough. Enough to leave a trace, if not a story. Enough to make someone someday stop and wonder, Not about who we were exactly, but whether someone once was, and whether the Earth, despite everything it's erased, kept a few stubborn signals hidden in its slow, silent archive. Next, we'll look at how some of these signs might behave in one of the most dynamic environments on Earth, the ocean. Because if civilization ever touched the sea floor, the ocean didn't just cover it. It may have taken it apart molecule by molecule. The ocean doesn't preserve secrets. It breaks them down. It scatters them, buries them, scrapes them away. To a civilization living near or interacting heavily with the sea, this might not have seemed like a threat. After all, water sustains life. It connects continents. It provides food, transportation, inspiration. But when it comes to preservation, especially over millions of years, the ocean is a relentless editor, erasing nearly everything it touches. And for a civilization that left its mark below sea level, the odds of us finding that mark today are almost non-existent. Still, it's worth asking, if a technological civilization had once existed and interacted with the ocean in any meaningful way, what kind of trace would it leave? And would that trace pass the test of deep time? Start with the basics. Today, most major cities are built near coastlines. It's practical. Access to trade, resources, and milder climates. But it also makes them vulnerable. Coastlines shift, storms erode, sea levels rise and fall, and in geological terms the oceans move dramatically. Over the last 20,000 years alone, sea levels have risen over 100 meters, flooding entire continental shelves. During past ice ages, vast areas of what are now underwater were dry land. Rivers ran through them. People lived on them. Now, those regions are submerged beneath layers of sediment and salt water, difficult to access and almost impossible to study comprehensively. This makes the search for any ancient civilization that lived along ancient coastlines inherently difficult. Not because it's implausible that such a civilization might have lived there, but because those are precisely the regions that have been erased, buried, or made inaccessible. Underwater archaeology is challenging at the best of times. Doing it on submerged continental shelves buried beneath layers of post-glacial sediment is something else entirely. Let's say some past civilization developed maritime technology, not just boats, but harbours, ports, maybe even coastal infrastructure. What happens to those structures over deep time? Wood decays, ropes rot, stone collapses, metal corrodes quickly in saltwater environments. Unless the structures were buried quickly under silt or sand in a low-oxygen environment, there's little chance they'd survive for more than a few thousand years, let alone millions. And even if they did survive, they'd be nearly impossible to detect without targeted high-resolution scanning. Artificial structures could theoretically leave some geomorphological traces, straight lines, unnatural angles, repeating patterns in the seafloor topography. But nature can produce surprising geometric features as well, and most underwater anomalies, once investigated, turn out to be natural formations. Without context or artifacts, it's difficult to argue otherwise. Now let's think bigger. What if the civilization wasn't just near the ocean, but used it intensively? Maybe for waste disposal, mining, or energy generation. Could those activities leave a signal? Modern humans, for example, have already left a clear geochemical footprint in the ocean. There are plastic gyres, massive floating garbage zones. There's mercury and lead contamination in deep-sea fish. There are radioactive isotopes from mid-20th century weapons testing. There are traces of industrial fertilizers causing dead zones near coastlines. And microplastics have been found at the bottom of ocean trenches, carried there by sinking currents and marine life. Some of these signals might persist for tens of thousands of years, especially those buried in sediment. If an ancient civilization had introduced synthetic compounds or altered marine chemistry on a large enough scale, those changes might be detectable today, but they'd be subtle, And even if they were found, they'd have to be distinguished from natural processes, hydrothermal vents, volcanic activity, organic matter decomposition, all of which leave their own complex chemical signatures. This is the essence of what you might call the lost tech test. Could the technological activity of a long-vanished civilization survive in a way that's still legible today? And if it did, would we recognize it as artificial? Or would we classify it as an unexplained anomaly? Or worse, overlook it entirely? Consider synthetic molecules. Some modern plastics and industrial chemicals don't exist in nature and are extremely resistant to degradation. A few, under certain conditions, could last for hundreds of thousands of years. Buried in anaerobic sediment on the seafloor, fragments or residues might survive. But again, the challenge is scale. One fragment means little. A widespread pattern means more. And patterns are harder to find than artifacts. They require data from across regions, depths, and time frames, something that's only just beginning to happen in marine science today. Then there are heavy metals and rare earth elements. Used in electronics and industrial processes, these elements are mined, concentrated, and often discarded. In theory, unusually high concentrations in sediment layers could point to processing or pollution. But many of these elements occur naturally in volcanic and hydrothermal systems, and distinguishing artificial from natural enrichment isn't always clear-cut. You'd need ratios, context, and a very precise understanding of what the natural background levels were at the time. Even underwater mining leaves ambiguous traces. Modern deep-sea mining has already been proposed for extracting manganese nodules and other valuable resources. If something similar happened in the distant past, the only clues might be altered sediment composition, disturbed layering, or the absence of expected minerals. But how do you detect an absence, and how do you prove it was caused by technology? Energy use is another angle. Any civilization reaching a certain level of complexity is likely to consume significant energy. That leaves waste heat, emissions, and byproducts. In humans, this includes carbon dioxide, industrial gases, and thermal pollution. In the ocean, it includes increased water temperatures near industrial zones, altered currents, and chemical runoff. If a past civilization used energy sources that produced durable byproducts, radioactive materials, synthetic chemicals, some of those might be detectable in ancient sediments. But again, only if they were widespread or concentrated enough to stand out. The problem isn't that these traces can't exist. The problem is that even if they do, they don't immediately scream civilization. They look like chemistry, like anomalies, like odd blips in a dataset full of natural variation. And unless they're accompanied by something more obvious, geometry, repetition, tools, or clear signs of construction, they remain unexplained. Just more noise in the long, slow signal of the planet. So the lost tech test is a real challenge. It's not about whether technology existed. It's about whether the right combination of materials, processes, and environments could allow even a sliver of that technology to be found after tens or hundreds of millions of years, and whether anyone would know what they were looking at if they did. Next, we'll turn to the surface again, not to look for what's gone, but to listen for what remains. Because while the ocean wipes things clean, some places hold on to stories for much longer. And sometimes those stories show up in the most unexpected forms, not in metal or stone, but in memory, in tales passed down, and in echoes too strange to ignore. When people talk about cities lost to the sea, the first names that come up are usually Atlantis or Lemuria. Myths passed down, half remembered, often repurposed by fiction and fantasy. But the real ocean has been swallowing real cities for a very long time, and not one of them left behind anything close to a monument under the waves. The sea doesn't preserve, it dismantles. It works slowly, but it doesn't stop. And when a city falls into it, what remains after a few thousand years, let alone a few million, isn't stone columns or mosaic floors. It's silence. Coastal regions have always drawn civilizations, fertile land, easy access to trade, predictable weather patterns. These are the conditions under which complexity tends to form. And yet, by building on the coast, you're also building on a fault line between stability and motion. Coastlines aren't fixed. They migrate with tides, storms, earthquakes, and the long, slow breathing of glacial cycles. Sea levels rise and fall, land lifts and sinks. What is now dry land might have been seabed 50,000 years ago, and what is seabed today might have been a settlement before the ocean came for it. Take Dwarka, a site off the coast of India, often cited as one of the oldest underwater urban ruins ever found. Some structures there appear to be man-made, but the exact nature of the site remains debated. Erosion, biological growth and sedimentation have altered the materials. Other examples include Pavlopetri off the coast of Greece, or parts of the Doggerland region in the North Sea, once inhabited, now submerged. In each case, traces are faint, fragmentary, difficult to interpret. They're found not because they're well preserved, but because they're close, shallow, and recent. Go further back in time, and the ocean doesn't just bury, it erases. The sea floor is constantly being reshaped. Currents redistribute sediment. Marine organisms colonize and transform surfaces. Corrosion eats away at exposed metal and concrete. And most importantly, new layers are always being added. Anything that isn't buried quickly and deeply enough gets broken down by chemical, mechanical, or biological processes. This is why submerged cities don't look like cities for long. Even stone structures can't withstand the combined effects of salt water, wave energy, and bioerosion. Over centuries, corners round off. Carvings fade, mortar dissolves, organic material disappears entirely, and eventually, what's left blends in with the surrounding geology. A tumbled wall might become an underwater ridge. A collapsed building might be mistaken for a natural rockfall. And that's for cities that have only been underwater for a few thousand years. Imagine one that's been gone for 10 million. Even if it had once stood with towers and streets and architecture far beyond our own, the ocean would not have kept it in a recognizable state. It would have chewed it down, turned it over, and scattered the pieces until they were indistinguishable from seabed rubble. There's also the issue of accessibility. Most of the ocean floor is still unexplored. We've mapped the moon in more detail than we've mapped the deep sea, and even when we do survey it, resolution is often low. It's enough to find seamounts and trenches, but not enough to pick out small features, especially if those features are buried or degraded. Sonar, submersibles, and core sampling help, but they're slow, expensive, and limited in scope. If something's there, it has to be obvious, or we have to already know where to look. Otherwise, it stays hidden. Some researchers have tried to approach this problem by studying sediment cores from ocean basins. These cores act like time capsules, preserving the chemical makeup of seawater, dust, and organic matter, going back tens of millions of years. They can tell us about temperature, salinity, productivity, and major disturbances, volcanic eruptions, asteroid impacts, and even abrupt climate events. And sometimes they contain strange signatures, a sudden spike in carbon, a layer rich in metals or rare isotopes. But none of these so far have been linked to civilization, at least not conclusively. That doesn't mean the signals aren't there. It means we may not yet have the tools or the frame of mind to interpret them that way. If an ancient civilization built coastal infrastructure, if it produced waste that entered the oceans, if it altered marine ecosystems on a wide scale, some trace of that might exist in the chemical record. But those changes would have to be significant, global, and rapid to be distinguishable from natural processes. And even then, the story would be hard to piece together. Think of the Fukushima nuclear accident in 2011. Within days, radioactive isotopes entered the Pacific Ocean. Within months, they were measurable off the coast of North America. That's a modern, well-documented event with known causes and precise measurements. Now imagine trying to detect something similar 50 million years after the fact, with no records, no context, and most of the original material long decayed or diluted. Even if the isotopes persisted in some form, distinguishing their origin would be guesswork at best. The ocean is not just a storage space, it's a processor. It cycles water, nutrients, and sediment through physical and biological systems. It chews up evidence and incorporates it into the broader churn of the planet. Cities don't sink and sit there untouched like Atlantean ruins. They dissolve, they blend, and unless you catch them in the act of vanishing, they become part of the sea's deep memory. A memory written not in maps or ruins, but in gradients of chemistry and shape. So if a city falls into the sea and no one remembers it, was it ever really there? From a geological standpoint, probably not. Or at least not in a way that's easy to prove. But these sunken landscapes still matter, not because they hold proof, but because they remind us of how quickly complexity can vanish, of how fragile presence is, even when carved in stone. They're not relics of forgotten civilizations from 100 million years ago. They're warnings, previews, soft shifting reminders that permanence is something humans invented and that nature doesn't recognize. We'll move next from the sea to the stone, from things buried by water to things sealed in rock. Because while the ocean devours, geology sometimes preserves. And once in a while, the planet itself seems to hold on to something it shouldn't. Not a building or a script, but a mystery, a thing that doesn't belong. And the closer we look, the more it seems to whisper that history might not be finished telling us what it knows. When scientists study rock layers, they're usually looking for patterns, clear sequences that help explain what the Earth was doing at a particular time. Was the climate hot or cold? Were there volcanoes? Oceans? What kind of life existed? Each layer is like a data point, a page in a planetary logbook written in minerals and dust. But now and then they find something that doesn't quite fit, something out of place or out of time. These are called anomalies, and while most eventually get explanations, some still sit in the margins, waiting for new tools or new ideas to make sense of them. Not all anomalies are mysterious. Geology is full of unusual but natural formations, mineral inclusions, fossil oddities, complex layering caused by environmental shifts. But every so often, something turns up that resists easy classification. A fragment that looks manufactured, a composition that doesn't match the surrounding matrix, an object embedded in stone that seems too regular, too shaped, too deliberate. Take the case of the famous artifact in coal stories, mostly from the 19th and early 20th centuries. Miners occasionally reported finding metal objects inside lumps of coal. Sometimes it was a chain, other times a bell or a piece of carved stone. These claims were often poorly documented, with few surviving samples and no clear provenance. Skeptics rightly pointed out that mining is messy. Coal seams can break, collapse, mix with modern debris, and confirmation bias was probably a factor. People saw what they expected or wanted to see, but the stories remain, not because they prove anything, but because they highlight the kinds of signals people think to look for. Then there are the metallic spheres found in South African mines, often cited by fringe theorists as evidence of ancient technology. These small, grooved objects were embedded in Precambrian rock, more than 2 billion years old. But studies showed they were likely natural concretions formed by mineral accumulation under high pressure. The grooves may have come from natural deformation. Interesting, yes. Manufactured, no. Anomalies like these often sit on the edge of scientific attention. Some are never investigated thoroughly because they lack context. Others are dismissed because the burden of proof for an extraordinary claim is, rightly, very high. And most can be explained with a little time, better sampling, or new data. But a few remain unexplained, not proven artificial, just unresolved. And that's the key point. The scientific process is cautious. It doesn't leap to conclusions. It favors known mechanisms over unknown ones. And it demands repeatable evidence, not one-off curiosities. So even if something strange is found in ancient rock, the first questions are always the same. Could this have happened naturally? Is there contamination? Was the layer disturbed? Has the sample been verified by multiple methods? Unless the answer to all those is clear, the anomaly stays in limbo. Still, not all anomalies are physical objects. Some are chemical. Take, for instance, the isotope excursions, abrupt planet-wide shifts in the ratios of certain elements, like carbon or oxygen. These are visible in rock layers as sharp changes in geochemistry. Most have known causes, massive volcanic eruptions, methane releases, or asteroid impacts. But the mechanisms aren't always fully understood. Some events show signs of rapid warming, ocean acidification, and extinction, all packed into a thin slice of geological time. Some scientists have compared these to what we're doing now with industrial emissions, and a few have asked, quietly, whether such patterns, if found in the distant past, could ever point to intelligent activity. The answer is usually no, not because it's impossible, but because there's no reason to jump to that conclusion. Intelligence isn't needed to explain most geological events. But what if one of these anomalies couldn't be explained by any natural process we know? What if a particular layer had chemical signatures that match industrial processes precisely? Synthetic molecules, stable isotope ratios, rare metals, distributed globally and with no volcanic or astronomical source? That would be harder to dismiss, but we haven't found one. Or if we have, it's sitting in a database somewhere labelled unusual, waiting for a question that hasn't been asked yet. It's also worth remembering that many discoveries come not from looking for something specific, but from noticing something odd and refusing to ignore it. Plate tectonics, for example, was once considered fringe. So was the idea that an asteroid wiped out the dinosaurs. The data was there for decades, but it didn't make sense until someone connected the dots. Anomalies are only meaningful when someone takes the time to see what else they might be saying. And that's where this ties back to lost civilizations. If any traces exist, they might not be dramatic. They might not be carvings or artifacts. They might be subtle, an unusual mineral deposit, a strange distribution of metals, a synthetic molecule embedded in an ancient layer. Things that, on their own, don't say technology, but together might raise the possibility. It's also possible we've already found some of these things, but interpreted them through the lens of what we expect to find. A pattern in geology that looks like a result of natural weathering. A layered structure dismissed as a sedimentary oddity. A geochemical spike explained by a massive bloom or a methane burst. And most of the time, that interpretation is probably right. But what if, in rare cases, it isn't? We don't know how a truly ancient civilization would manifest in the rock record. We don't know how long its traces would last, but we do know what does last. And it's in those lasting things, the anomalies, the residues, the unexplained patterns, that any signal, however faint, would have to live. And so we keep looking. Not with the expectation of a buried city, but with the quiet possibility that somewhere, layered deep beneath our assumptions, there's a message not in words but in data. Not left intentionally, but left all the same. Next, we'll take a brief step away from geology and into a different kind of record. Not carved into stone, but carried through stories. Because sometimes history doesn't disappear. Sometimes it echoes. And the line between memory and myth can be thinner than we like to admit. When archaeology runs out of artifacts and geology runs out of layers, what's left are stories. Not scientific records, not measurements, but myths. Oral traditions passed down through generations, sometimes across entire civilizations. Most are changed in the telling. Details shift, meanings blur, symbols layer over each other. But myths persist. They survive even when buildings fall and languages die. And while they're rarely taken as literal history, there's a growing understanding that some of them may hold fragments of real events, coded, distorted, but not entirely imagined. This idea isn't new. Cultures around the world have myths about floods, fire, stars falling from the sky, or land that once was but is no more. They describe golden ages that ended suddenly, lost knowledge, sudden darkness, strange visitors, islands swallowed by the sea. Taken separately, each story sounds like symbolic fiction. Taken together, they begin to form patterns, shared anxieties, shared experiences, perhaps even shared memories of events that happened long before written language existed. One of the most persistent themes is the flood. It appears in Sumerian, Babylonian, Greek, Hindu, Norse, and biblical traditions, among many others. The details vary, but the core is consistent. A vast deluge wipes out a previous world, often as punishment or renewal. Sometimes a few survivors are warned. Sometimes they build boats, sometimes they climb mountains. It's tempting to see this as simple metaphor, an explanation for seasonal rains or a reflection of human vulnerability. But there's also geological evidence of dramatic sea level rise and coastal flooding, especially at the end of the last ice age. Glaciers melted, seas rose by over 100 meters, and entire landscapes were drowned. People living near those coasts would have seen their world vanish, and their descendants may have told stories about it. Other myths speak of lost lands: Atlantis, Mu, Kumarikandam, High Brazil. These places are often described as advanced, beautiful, and doomed. The reasons vary: hubris, war, cosmic punishment, but the endings are always the same. The land sinks, the people vanish, and only the tale remains. Most of these stories are viewed today as fiction, inspired by philosophical allegory or nationalist folklore. But even fiction can preserve echoes. The memory of a submerged land might be real, even if the details are not. There are also stories of knowledge lost. Many traditions speak of a time when people knew more, when ancient wisdom was common, when the stars were understood, when the earth was shaped deliberately. These ideas aren't proof of anything, but they do raise a question. How do cultures come to believe they used to know more than they do now? Not every tradition holds this view, but the ones that do often describe a fall, not just a moral one, but a loss of information, of skill, of contact with something greater. And then there are the anomalies in ancient texts. Tales of machines, flying vehicles, cities in the clouds, weapons with unnatural power. In most cases, these are clearly metaphorical or symbolic, but occasionally the descriptions get oddly specific. Too specific, some argue, to be pure invention. Defenders of the myth as memory idea suggest these might be distorted recollections of something real. Technologies or events passed down through oral tradition, long after the original context was lost. It's a difficult position to test scientifically. Myths aren't evidence. They're not dated. They don't come with calibration marks or geological context. But they are part of the human record. And when multiple cultures tell similar stories without clear contact, it's worth asking why. Modern scholars in anthropology and archaeology have begun to revisit this question, not in search of ancient astronauts or secret continents, but to better understand how oral history works, how stories are preserved, adapted, and passed down. In some indigenous traditions, oral accounts have proven remarkably accurate when matched with archaeological or environmental evidence. Entire landscapes have been described in stories: river paths, glacial retreats, volcanic eruptions, centuries before written records. This means that myths aren't just fantasy. They're compressed history, shaped by culture and language, but rooted in experience. They may contain metaphors, yes, but metaphors for something. And sometimes, with enough patience, those metaphors can be decoded. None of this proves that an earlier civilization existed, but it does complicate the idea that history begins with writing. The absence of a script doesn't mean the absence of memory. And in a world where physical evidence is fragile but stories can last for thousands of years, maybe myths deserve a second look. They might not tell us what happened, but they might tell us that something happened, and that it mattered enough for people to try and preserve it in the only form they could. we'll continue by turning our attention to the ground, literally, to the bits and pieces we've pulled from the earth that seem, at times, out of place. Not myths, not metaphors, but materials. Things with shape, weight, and texture. Some ordinary, some strange, and some that raise just enough questions to keep this old idea alive. Tektites are small, glassy objects scattered across parts of the Earth, often dark in colour, aerodynamic in shape, and surprisingly consistent in composition. Most geologists agree they're the product of impact events, formed when a meteorite strikes the planet, melts the local rock and sends droplets of molten material into the atmosphere, where they cool and fall back to the ground. They're fascinating, but not mysterious. At least not in isolation. What becomes more interesting is how often these odd bits of material, tektites, metal fragments, shaped stones, get lumped into stories that stretch beyond geology. Stories of lost technologies, vanished builders, tools where there shouldn't be tools. And while most of these claims don't survive scientific scrutiny, some of the artifacts they center on are real. Not alien, not magical, just hard to classify. They sit in museum drawers, misfiled or unstudied, not because of conspiracy or negligence, but because science moves on when something doesn't fit cleanly. Take the so-called out-of-place artifacts. Usually shortened to OOPArts, these are objects said to have been found in geological strata that predate human history. Examples include metal spheres in billion-year-old rock, carved objects in coal, or machined-looking items embedded in stone. Almost all of them have been explained as misidentifications, hoaxes, or natural formations. But the persistence of these stories tells us something, not about ancient machines necessarily, but about how hungry people are for a different narrative, one where civilization didn't start 10,000 years ago, but has been coming and going for much longer. Sometimes these artifacts are genuinely curious. A polished stone ball with perfect symmetry. A copper tool discovered in a layer thought too old for metallurgy. Or a carved pattern found deep in a cave where no known culture was thought to have reached. In nearly every case there are natural explanations, or at least plausible ones. Geology can produce surprisingly regular shapes. Chemical weathering can etch rock in strange ways, and tools can move through layers due to animal activity, groundwater shifts, or human error during excavation. But even if none of these objects turn out to be the smoking gun for a lost civilization, they raise an important point. The deeper you go into the past, the harder it becomes to prove or disprove anything. Sediment gets churned, caves collapse, dating methods rely on context, and context can be lost. If a technological object were buried in a layer 10 million years old, and it didn't match anything we knew, we wouldn't automatically conclude it was ancient. We'd probably assume contamination, a misplaced sample, a modern object that found its way down. And most of the time, that would be right. But that assumption, though statistically sound, makes us almost blind to the rare cases where it might be wrong. Tools, real tools, can survive for a long time under the right conditions. Stone tools, in particular, are resilient. We found chipped flints over 2 million years old, showing deliberate shaping, clear use wear, and evidence of cultural transmission. What's notable is that it took a long time for archaeology to recognize some of these artifacts as tools at all. For years, many were dismissed as geofacts, naturally broken stones. Only when patterns emerged, repetition, clustering, wear marks, did the scientific community begin to accept their human origin. This has a direct lesson for the search for any non-human civilization. The first signs wouldn't be cities or machines, they'd be patterns, tools that don't match local geology, arrangements of materials that suggest planning, regular shapes appearing more often than chance would allow. But those signs would be extremely easy to overlook, especially without context. And context is fragile. Imagine finding a perfectly shaped sphere in a layer of rock dated to 100 million years ago. The immediate assumption would be that the layer has been disturbed, that the object is intrusive, and that might be true. But if we automatically dismiss every anomaly that doesn't fit the known timeline, we close the door to discovering anything that might change that timeline. Then there are the tall tales, stories passed down or published in fringe journals about impossible finds, an iron nail in sandstone, a mechanical device in coal, a human footprint next to a trilobite. These claims, almost always, fall apart under investigation. Poor documentation, no surviving sample or obvious tampering. But not all are deliberate hoaxes. Some come from well-meaning observers who didn't have the tools or background to interpret what they found. And some are just mistakes, natural features that looked artificial in the moment. Yet the idea behind these stories that something came before isn't inherently wrong. What's usually flawed is the evidence presented, but the motivation is understandable. People want to know that history is deeper than we think, that our story might be part of a longer, more complex arc. And in a way, that's not just hopeful, it's logical, because intelligence isn't a one-time event, it's an emergent property, and over billions of years it's reasonable to ask whether it's happened more than once. Science, of course, demands more than curiosity. It demands data, repeatability, rigor, but it also requires questions, and some of the best questions start with outliers, with things that don't fit. Most anomalies turn out to be nothing, but a few lead somewhere new. So even if the tektites are just splash-form glass, and the tools are from known species, and the tall tales are just that, they still have a role to play. They remind us to look closer, to wonder what might have been missed, and to accept that the line between natural and artificial, between coincidence and pattern, isn't always obvious. Next, we'll step further into that uncertainty, because not every intelligent culture would have developed in the same way. Not every civilization would have chosen stone or metal, and if some never did, their remains, if they exist, might be so subtle we've already walked past them, unnoticed, unmarked, but not entirely gone. When we picture a civilization, we tend to imagine certain things: tools, buildings, machines, writing, monuments, and almost all of it is made of or shaped by metal. It's foundational to how we define technological progress. The Stone Age, the Bronze Age, the Iron Age. But that framework assumes one path, one model, one ladder. And it's easy to forget that metal isn't a requirement for intelligence, or even for complexity. It's just what we used. So what if a different civilization never reached for it? What if it evolved, flourished, and vanished without ever needing to extract metal from rock? The idea isn't far-fetched. In fact, for most of our own species' history, we lived without metal. Early humans crafted stone tools built with wood and bone, used fire, understood animal behavior, made clothing, decorated their homes, and developed rich oral traditions. All without smelting a single ounce of ore. Many indigenous cultures continued to thrive with limited or no metalwork even after contact with those who did. Complexity doesn't begin with metallurgy. It only becomes visible to archaeologists in certain ways because of it. So if we consider the possibility of a pre-human or non-human civilization, it's worth asking, what would their record look like if they never entered a metal age? The short answer is, it would be incredibly hard to find. Organic materials, wood, plant fiber, animal hide, even bone, decompose rapidly unless preserved in extremely dry, frozen or anaerobic environments. Textiles rot. Wood burns or decays. Anything left exposed to moisture, heat, or biological activity breaks down. Without stone or metal or ceramic to carry the memory of those objects, nothing stays put for long. And even when preserved, organic remains are rarely interpreted as technological unless they show obvious shaping or patterning. A bundle of fibers might be string, or roots, A hollowed-out log might be a canoe, or just a log. Now consider a hypothetical civilization that built entirely from biodegradable materials. Shelters of woven plant fiber, tools made from hardwoods, containers from gourds or leather, decorations, clothing, written symbols, everything done with natural pigments, feathers, bark, sand, smoke. Nothing mined, nothing smelted, nothing left to rust or fracture into durable fragments. In the right climate, that society could exist for thousands of years and leave behind almost nothing we'd recognize in the geological record. A forest could grow over it in a decade. Erosion could take the rest. And in 1,000,000 years, not a trace. Even fire, one of the oldest and most transformative technologies, doesn't preserve well. You can find charcoal layers, ash beds, fire-cracked rocks. But those are common in nature too. Lightning strikes, wildfires, volcanic activity, they all leave similar marks. Distinguishing a fire used by intelligence from one caused by natural forces requires context. Hearths, patterns, associated artifacts. Without those, it's just another black layer in the soil. Some non-metal tools could survive, especially stone. But not all stone tools are obvious. A pebble used to grind grain or soften fiber might never be shaped. A sharp rock used to cut might not be retouched. If tools aren't curated, kept, stored, reused, they blend into the natural background. And if they're used in ways that don't create lasting wear patterns, they're nearly impossible to identify after the fact. It's also possible a civilization could reach high levels of understanding, astronomy, agriculture, even medicine, without needing heavy industry. Knowledge isn't always tied to material excess. A society might map the stars with naked eye observations, track seasons with stone or wooden markers, or breed plants through careful observation and selection. They might tell time with water, compute with knots or beads, pass down knowledge through encoded song. Nothing in those systems demands metal, only continuity. And if that continuity breaks, by natural disaster, disease, migration, the knowledge can be lost just as quickly as the tools decay. Language especially is fragile. Spoken words vanish with the speaker. If not written or carved, they disappear entirely, and even written records can fade. Paper burns, bark and leaves decay. Inscriptions in sand, dust, paint or wood don't last unless intentionally preserved. So if a civilization never developed a durable script, or never needed one, we might never know it existed. And then there's the question of scale. Not all civilizations build cities. Some remain mobile, some blend into their ecosystems, some value impermanence. Our definition of advanced is biased toward what leaves big footprints. Architecture, pollution, energy use. But those are cultural choices, not inevitable steps. A society could be technologically sophisticated, even philosophically advanced, and still choose to live in ways that minimize its geological impact, especially if it learned, through experience or disaster, that high-impact lifestyles lead to collapse. In that case, what signs would remain? Perhaps modified landscapes, terraced hillsides, altered river paths, plant species growing far from their origin points. Maybe traces of fire management, soil enrichment, or intentional biodiversity patterns. But these things are subtle. They blend into natural processes, and they're easy to overlook or to interpret as accidental. We already see this in our own world. Amazonian terra preta, dark, fertile soil enriched by ancient communities, is still not fully understood. It contains charcoal, bone, pottery shards, and organic matter layered in ways that suggest deliberate engineering, but it doesn't look like a city. It looks like dirt, and for a long time, it was dismissed as just another soil type. Only now are researchers beginning to realize it might be the legacy of a complex, organized society with deep agricultural knowledge and landscape control. If something similar had happened 100 million years ago, With less pottery, fewer tools, and entirely biodegradable structures, it might never be noticed at all. Especially if it happened in a region that's now underwater, eroded, or tectonically subducted. So civilizations without metal may not be lost because they failed. They may be lost because they succeeded in living lightly, in blending with their environment, in valuing cycles over monuments. And from a preservation standpoint, that success becomes invisibility. We tend to think of progress as a trail of artifacts, but the absence of those artifacts isn't always a lack. Sometimes it's a decision, or a consequence of different priorities, or simply the result of being erased by time, which never promised to keep our records in the first place. Next, we'll look at the silence this all leaves behind. Not just the physical gaps, but the deeper uncertainty. Because even with everything we know about geology, archaeology, and history, there are still places where nothing speaks. And that silence might be telling us something, or hiding something that once did. Soil holds memory, but it doesn't speak loudly. It remembers what grew, what died, what burned, what passed through. It records footsteps sometimes. It absorbs blood, ash, rainfall, decay. But it doesn't shout its history. It holds on to it quietly and only in pieces. If you dig into it with the right tools, you can sometimes find a story, but more often you find silence. And in that silence, we start to realize just how fragile the record of a civilization really is. We think of soil as surface, but in many ways it's an interface, a transition zone between the living and the non-living. It's where biology meets geology. Every leaf that falls, every organism that dies, every root that pushes through it is shaping the layer beneath us. And over time, those layers compact, they fade into sediment, and if they're buried deep enough, they become stone. But most soil doesn't last that long. Most of it is turned over, eroded, washed away. So the traces that do survive are rare, and those that do often don't tell you much on their own. There are places where soil carries a clear signal of past life. Ancient hearths leave behind char. Collapsed homes leave behind organic stains. Burial sites show patterns of human activity, discoloration, disturbed layering, chemical shifts from decaying bodies and offerings. But these signs are fragile. Even a few thousand years of weather or agricultural activity can erase them, and in geological time they don't hold up well, unless sealed in an unusually stable environment. Frozen tundra, arid deserts, peat bogs, they break down. This is part of why most ancient civilizations are found through stone and metal, not soil. The information in dirt doesn't last without context, and when it's stripped of that context, disconnected from artifacts, architecture, or clear stratigraphy, it stops telling a coherent story. It becomes noise, or it becomes nothing. Still, researchers have begun to develop better ways to read that silence. Archaeobotany, for example, studies tiny plant remains, pollen grains, phytoliths, seeds, to reconstruct ancient landscapes. Geoarchaeologists look at soil chemistry, texture, and layering to infer human activity. Blackened soil layers might suggest controlled burning. Phosphate concentrations might indicate habitation or waste disposal. Unusually fertile patches might point to long-term agriculture. But even these clues require interpretation. High phosphate doesn't automatically mean people lived there. It could come from animals. Dark soil might be a hearth or a lightning strike. Soil enriched by charcoal might be deliberate, like Amazonian terra preta, or just the result of a firestorm. Without context, without repeated patterns, these traces don't rise above the background of natural variation. And so, when we ask whether another civilization might have existed in the deep past, we have to face this reality. Soil won't confirm it, not alone, not after millions of years. Because even if such a civilization once altered the land, grew crops, built homes, shaped environments, those changes would almost certainly have been reabsorbed, worked back into the matrix, turned over, washed out, compressed, or simply erased. it's a difficult idea to accept that a whole society, its knowledge, its cities, its memory could vanish so completely that even the ground it stood on forgets it. But that's the nature of time. Not cruel, just indifferent. If nothing resists, nothing remains. And soil as a medium doesn't resist much. It cooperates. It recycles. It keeps the cycle moving. And there's another problem. Even if a few residues do survive, how would we know they weren't natural? How would we recognize the difference between an ancient garden and a wild meadow? Between a fire pit and a burnt patch of ground? Between a footpath and a game trail? The longer ago it happened, the less those distinctions matter. At a certain point, activity and accident become indistinguishable. We also have to consider that what survives is not necessarily what mattered most. Stories don't fossilize. Relationships don't show up in core samples. Songs, rituals, ideas, they leave no chemical marker. And even when objects survive, their meaning often doesn't. We've found ancient tools we still don't understand, languages we can't read, symbols we can't decode. And those were from civilizations we know existed. The gap left by an unknown one would be even wider. So when we sift the soil for answers, we have to be honest about what we're looking for, and what we're willing to recognize as significant. A strange chemical spike, an unusually fertile band of earth, a layer of char in an unexpected place. Are these signs of intelligence, or just noise? The line is blurry, and in deep time it's almost invisible. But the silence itself is a kind of answer. It tells us that even intelligence, even culture, can pass without notice. That the earth doesn't differentiate between life that shaped itself through instinct and life that shaped itself through thought. And that unless something lasts, something durable, strange, unmistakably artificial, it will be lost to the cycle. Just another layer, just another shade in the soil. Next, we'll turn from silence to speculation, not about what we'd find if they existed, but what they might find if we disappeared. Because imagining how our own civilization might look from the future gives us the clearest window into what traces a lost one might leave behind, and what it might take to notice them at all. If humanity vanished tomorrow, the world would notice at first. Silence in the cities, lights going out, planes grounded, roads empty. But in geological time, that silence wouldn't last. Our absence would register for a moment, then begin to dissolve. What would remain, though, is the question that connects directly to everything we've asked so far. Not what we are while alive, but what part of us might persist when there's no one left to explain it. If future beings, human or otherwise, ever looked back at the layers we're building now, what would they actually find? Some signals would be unmistakable. The chemical composition of our atmosphere, for example, is already changing in ways that are visible in ice cores and ocean sediments. Carbon dioxide levels are spiking at a rate unprecedented in the last several million years. Methane concentrations are up. Nitrogen cycles have been altered by fertilizer use. These changes are global and synchronous. Sharp, unnatural spikes in what had been a relatively stable pattern. Even without knowing the cause, future geologists would see that something big happened during our time. Plastics are another marker. Synthetic polymers are being deposited almost everywhere. Landfills, rivers, oceans, mountain snow. Microplastics are found in marine sediments, in fish, in human blood. They're resistant to decay in many environments, and even if broken down into smaller fragments, their chemical fingerprints might remain. Future researchers might find thin layers of microplastic-infused sediment appearing abruptly in the geological record and distributed planet-wide. They'd stand out, not because plastic is indestructible, but because it's distinct, unnatural, a layer made of things the planet never made on its own. We're also altering the mineral composition of the planet in subtle ways. Industrial processes create new minerals, some never before seen on Earth. fly ash from coal combustion, slag from metal smelting, concrete particles, synthetic pigments, artificial alloys. These technofossils are forming now, often embedded in concrete or buried in landfills. In the distant future, they might show up as anomalous inclusions in sedimentary rock, sharp-edged fragments with precise ratios of elements that don't naturally cluster together. Then there's radiation. Above-ground nuclear testing in the mid-20th century scattered isotopes across the globe, cesium-137, plutonium-239, and others. These isotopes decay at known rates, but they're measurable even now in soil, ice, and the bones of animals. The radioactive signature from this brief but intense period could persist for tens of thousands of years, possibly longer in shielded environments. To a future observer, it would look like a sudden burst of radiation with no apparent natural cause. Our cities, ironically, wouldn't last long. Above ground, buildings would collapse from neglect within decades. Still rusts, concrete cracks, glass shatters, rebar expands. Plant roots pry open foundations. Moisture seeps into every crevice. In 1,000 years, most structures would be unrecognizable, buried, eroded, overtaken by forest or desert. In 10,000, you'd have to dig to find the remains at all. Only in places where urban layers are rapidly buried by flood, landslide, or volcanic ash might intact structures survive long enough to fossilize. And even then, they'd likely collapse into jumbled debris, stripped of form, disconnected from meaning. Deep underground, some structures might fare better. Subways, bunkers, mines, waste repositories, anything sealed from the surface might last much longer, especially if they're in geologically stable regions. Future excavators might find strange chambers filled with unknown materials or corridors carved with unnatural precision. But without records, without context, those too would be difficult to interpret. A data center might look like a cave. A missile silo might look like a natural void lined with strange minerals. Our machines, cars, phones, airplanes, satellites wouldn't age gracefully. Metal corrodes, wiring breaks down, plastics degrade. Buried in sediment, a few might last longer in partial form, engines fossilized in place, circuit boards turned into mineral composites. But most of our technology is designed to function, not endure. And once function is lost, the shape quickly follows. Our data is even more vulnerable. Magnetic drives lose coherence. Optical disks degrade. Solid-state storage can't hold charge indefinitely. The vast sum of our recorded knowledge, books, films, digital archives, would vanish unless preserved by accident. Carved stone lasts. Etched metal plates might. But hard drives, almost certainly not. Our entire digital culture could become a blank spot in the sediment, known only by what else was changing chemically while we were alive. Agriculture might leave longer fingerprints. The global reshaping of ecosystems, cleared forests, terraced hills, monoculture fields, has changed erosion patterns, soil chemistry, even plant evolution. Thousands of years from now, fossilized pollen might show sudden dominance of just a few species. Patterns of deforestation might leave odd carbon signatures in sediment. Future botanists could infer widespread cultivation. But again, without tools or texts, it's a partial story. Agriculture without farmers. Domesticated animals leave bones. They might show up clustered around ancient settlement sites. Dogs, cattle, sheep, pigs, all genetically distinct from their wild ancestors. Fish farms and livestock facilities might leave concentrated remains, chemical signals, trace antibiotics. If sediment locks them in fast enough, those bones might persist for tens of thousands of years, maybe more. Fossil fuels are also a signal. The massive extraction and combustion of coal, oil and gas leave distinct traces, not just in the air, but in soil and water. The isotopic signature of burned fossil carbon is already being detected, and in some future layer of rock, the shift will look sharp. Compressed into a few centimeters of sediment, it will signal a planet out of balance. Greenhouse gases rising, temperature climbing, oceans acidifying. A pattern never seen before. And possibly, if we disappear, never seen again. So what would we leave behind? Not monuments, not stories, but chemistry, isotope ratios, artificial molecules, strange minerals, a spike in carbon, a dip in biodiversity, a line in the rock, a signature sharp enough, fast enough, and global enough to say something intelligent was here, something that built and burned and buried itself in its own record. And for anyone, or anything, looking back millions of years from now, that might be enough. Not to understand us, but to know we existed. And maybe to wonder what happened. Next, we'll flip the question. If something came before us, if some earlier intelligence rose and fell long before we appeared, then where is their line? If the silence isn't proof of absence but of erasure, what would it take to not leave a mark? And how likely is it that someone already has? If a civilization once lived on this planet, millions, tens of millions of years before us, then the most pressing question isn't how they lived or what they made. It's this: where are they now? Not just physically, because erosion, subduction, and decay explain that part, but historically, narratively. If they were here, why is there no memory of them? No whisper? No lineage? Did they vanish? Did they transcend? Or did they simply end and leave behind a record too faint for us to recognize? The Earth is not a forgiving archive. It's an active planet, always in motion, always cycling. Plate tectonics grinds up the oldest crust and pulls it deep into the mantle. Erosion flattens mountains, spreads dust across oceans. Forests rise and fall, deserts shift, rivers redraw the land. Even without catastrophe, the planet itself is enough to erase nearly everything a civilization could build, given enough time. But the disappearance of physical things is only part of the problem. What we're really asking is why there's no clear cultural thread. No myths that obviously point to a pre-human intelligence. No traditions that preserve their knowledge. No clear break in the evolutionary record that suggests intelligent intervention or artificial modification. In short, no sign that anyone like us came before us. One answer is simply scale. Human civilization, as we know it, is just a few thousand years old. Agriculture is maybe 12,000. The industrial age, 200. The digital age, a few decades. And in that time, we've reshaped the entire planet. Now imagine a civilization that lasted just as long, 10, 20,000 years, but did so 50 million years ago. What would be left? A few layers in the sediment at most. And unless they seeded life, changed the genome of species, or left clear enduring artifacts, their influence might blend into the natural record. We often think of intelligence as a thing that accumulates, builds on itself, grows in complexity, leads to inevitable outcomes. But that's a projection. Evolution doesn't care about continuity. A species can go extinct in a single generation. A culture can collapse over a few seasons. Complexity is not a shield. An intelligence once lost doesn't guarantee a second attempt. They could have ended suddenly, a war, a climate event, a runaway technology, or just the slow attrition of stability, soil depleted, species lost, systems too interconnected to adapt. And if they collapsed, their population might have dropped rapidly, scattering, regressing, disappearing. With no one left to preserve their knowledge, memory would fade, language would unravel, stories would fragment and dissolve. Or they could have left, not to space necessarily, but to silence, to minimalism, to a way of life that deliberately chose to stop growing outward. Maybe they recognized that expansion had limits. Maybe they chose not to build monuments, but to blend, to scale back, and over generations they might have faded from the physical world without disaster or regret. Not a fall, but a letting go. In that case, they might have erased themselves so cleanly we'd never know they were here. There's also the unsettling possibility that they didn't live long enough to leave a story. That intelligence flared briefly, never reached critical mass, and was wiped out before it could establish memory. Not all sparks become fire, and in a world full of predators, natural hazards, and biological risks, a species might gain consciousness but not culture, or culture but not civilization, or civilization but not resilience. If we ask where they went, we also have to ask what we're assuming about they. Were they like us? Bipedal, tool-using, language-speaking, or something stranger, octopus minds, tree-dwelling network intelligences, oceanic collectives? Intelligence doesn't have to look like primates building machines. It could emerge in forms that don't leave the kind of traces we know how to look for. And if so, then we might be asking the wrong version of the question. Not where did they go, but what were they to begin with? Even if they were here, and even if they left some mark, recognizing it would require us to step far outside our assumptions. We'd need to notice not artifacts, but absences, not ruins, but disruptions. We'd need to be open to finding traces not just in rock or metal, but in genes, sediments, isotopes, patterns that don't align with natural processes, yet don't scream machine either. So maybe they didn't go anywhere. Maybe they were folded into the biosphere, recycled into dust and code and cell. Maybe we've already dug through their cities without knowing. Maybe the silicon in our microchips was once the foundation of their homes. Maybe their legacy isn't gone, just scrambled, diluted, repurposed by the relentless metabolism of the Earth. Or maybe, in some form, they're still here, not biologically, not consciously, but embedded in the systems they left behind. Reshaped ecosystems, redirected rivers, modified genomes. Structures too old to be labelled, too strange to be claimed, too ambiguous to be remembered. Remnants that don't announce themselves because they no longer recognise us as their audience. The deeper we dig, the more we understand that loss isn't always loud, endings don't always come with warning, and disappearance, especially on a planet like this, can be complete. Next, we'll ask a harder question. Not whether a past civilization existed, but whether we'd believe it even if we found the evidence. Because knowledge isn't just about data, it's about recognition and belief. When it comes to rewriting the story of who came before us, has always been the hardest part. Humility isn't something science demands, but it is something the universe tends to enforce. Every time we've assumed we were at the centre of things, we've been moved outward, first from the Earth, then from the Sun, then from any special place in the galaxy. And now, when we look at the deep past of our own planet and ask if we were the first to reach this level of awareness, we face another kind of decentralization. One that doesn't say we weren't first, but gently reminds us. We might not know either way. This is the humbling possibility, that intelligence is not unique, that it can arise more than once on the same planet, and that it can vanish so thoroughly we wouldn't even notice. Not because it didn't leave traces, but because we've already explained those traces away, or never saw them in the first place. We tend to think that if something important happened, it would be obvious. But that belief assumes permanence is normal. It isn't. The vast majority of human history has been lost even from the last 10,000 years. Entire cultures left no written records. Entire cities left no visible ruins. How much more could be missing from 10 million years ago? Or 100? The geological record isn't a book. It's a puzzle missing most of its pieces, with no picture on the box, and we only notice pieces that contrast sharply with the rest. Something black in a white layer, something jagged in a smooth one. The strange things get attention, the subtle ones disappear into the background. This is why the idea of a pre-human civilization is so difficult to explore, not because it's absurd, but because it exists in the exact space where evidence is weakest and interpretation is softest. It requires science to make room for doubt without abandoning rigor, to hold space for the unknown without filling it with fantasy. Most scientists don't resist the idea out of arrogance. They resist it out of training. Extraordinary claims require extraordinary evidence, and so far there isn't any. No machine parts in Permian rock, no coded messages in carbon layers, no structure, signal, or relic that requires intelligent origin and excludes all natural ones. But absence of evidence isn't evidence of absence, and sometimes the scale of time is so large that silence becomes the dominant feature, not because nothing happened, but because the Earth is good at forgetting. And that's where humility returns, not as a surrender, but as a way of staying honest. We don't know if we're the first. We may never know. And if we aren't, we may never find the proof. And if we do find it, we may not recognize it for what it is. Even now, as we map anomalies, study extinction events, trace chemical signals through the sediment, we're limited by what we expect to see. A buried city? We know how to interpret that. A spike in iridium or carbon? Maybe a meteor, maybe a fire, maybe something else. But it takes effort to see a pattern that doesn't already match one we've studied before. And this limitation isn't just scientific, it's emotional, cultural. If we accept that something like us came before us and disappeared, it reshapes what we think of as inevitable. Progress becomes fragile, civilization becomes brief, and intelligence becomes less of a crown and more of a chance, a thing that might come and go and come again, or not. There's also the question of meaning. If there was someone before us, someone who built, dreamed, wondered, failed, what does that mean for us now? Does it make us less special, or more connected? Are we their continuation, or their replacement? Are we repeating mistakes they made, or following a new path they never walked? We don't know. And that not knowing is part of the point. It's possible that the most lasting legacy of a prior civilization isn't material at all. It's conceptual. It's the very idea that they could have existed, that we might not be the first, and that someday someone might ask the same question about us. What will they see when they look back? A spike of carbon, a scattering of plastic, a brief shimmer in the sediment. Will they call it a civilization? Will they call it a tragedy? Will they call it proof that they are not alone? We imagine the past as something fixed, but it isn't. It shifts every time we look at it from a new angle with new tools or with new questions. And this question, the one about lost civilizations, isn't really about the past at all. It's about how much of the unknown we're willing to live with, how much wonder we allow into our model of the world. Not every mystery demands a solution. Some just want to be acknowledged, and this one, maybe more than any, asks us not for belief, but for attention. Soon, we'll bring this journey to a close. Not with an answer, but with a pause. Because for all we've asked, all we've speculated, the night still holds more than we can grasp. And maybe that's enough, for now. So here we are, at the quiet edge of the question. After all the digging, all the wondering, all the long walks through layers of stone and memory, and maybe, we're left not with certainty, but with stillness. And in that stillness, something gentle happens. The question softens, not because it's answered, but because it's been heard. Maybe we are the first, maybe we're not. Maybe intelligence is rare, or maybe it's shy. Maybe it blooms in hidden corners and fades before it leaves a mark. Maybe the Earth has carried more minds than we'll ever know, each flickering into awareness, shaping their time, then slipping quietly beneath the next layer. We search because it's what minds do. Not just to find, but to reach. Through time, through space, through possibility. The same curiosity that sends probes to other planets sends thoughts into the past, asking who else might have stood where we now stand. looking up, wondering, listening. And you, right now, wherever you are, whenever it is, you're part of that. Part of the long thread that ties questions to silence and silence to story. Even just by listening, by following this trail of thoughts through the dark, you're participating in something deeply human. Or maybe not just human, maybe conscious, maybe universal. Because sleep too is a kind of deep time, a letting go of the surface, a sinking into layers, and when you drift off tonight, you'll be entering a space not so different from the one we've explored. Quiet, vast, unlit by certainty. And maybe, just maybe, somewhere in that stillness, the minds that came before, if they came at all, will meet yours in passing, not with answers but with company. So rest now. Not because the questions are over, but because you've carried them far enough for one night. The past will wait, the earth will keep spinning, and whatever came before, whatever comes next, you're here now. Sleep well, time traveller.